Dear folks, we are going to learn about the how to simplify the industrial problem into a linear programming model so that we can find out the solution. A manufacturing firm, a manufacturing firm produces two products. Each product must undergo an assembly process and a finishing process. So two processes has to be done for every product, every of the two product. It is then transferred to the warehouse. When it is assembled and finished, it is transferred to the warehouse, which workspace for only a limited number of items, which has a space. Obviously warehouse has a limited space. It may be a very expensive place to put the inventory for a lesser period of time. The firm has 80 hours available for assembly. So this is the constraint. You see that the maximum hours is 80, so it is a maximum hours. So it is the less than, so you see it is the less than, the firm has 80 hours available for assembly, so it is the maximum hours, and 112 hours for finishing, so it is the maximum finishing hours, and it can store maximum of 10 units in the warehouse. So this is the maximum unit. So you see everything you see is at the maximum side. Inequality must be less than and equals to, because it is the maximum units possible in the warehouse, maximum hours available for finishing process, and the maximum hours available for assembling process. Let's move ahead. Now you see each unit of product 1 has a profit of $30 and requires 4 hours to assemble and 14 hours to finish. So it has a lot of information. First you see the profit maximization function has to be made because the profit is given. Next, and requires 4 hours to assemble. So the product 1 requirement is 4 hours to assemble, 14 hours to finish. Since we know that the assembling and finishing has to be separated, so as a separate constraint, it has to be dealt with in separate constraint. So you see the 4 hours to assemble and 14 hours to finish. So 4 hours of assembling and 14 hours to finishing. You see each product 2 has a profit of $70 and 10 hours to assemble and 8 hours to finish. So you see 10 hours to assemble and 8 hours to finish. So product 1 and 2 assembling time you see, and it is the finishing time. So it is very important. You need to understand that every unit must be in the same right hand side, the left hand side of the constraint must be of the same measurement scale. So they are in both in the hours. They must both in hours. If they are not in hours, then this equation will not be solved correctly. So they must be in hours. So you see 4x plus 10y, that is the assembling duration. 4 is the hours for assembling product 1, and 10 hours is for assembling the product 2. The total hours already given, we already discussed in the last page, that 80. So that is the maximum. Okay, that is why it is equals to and less than inequality. And the next constraint you see 14 hours finishing time for product 1 and 8 hours finishing time for product 2, and that must be maximum side. So inequality is less than and equals to 112. So 112 is the maximum hours available. Now let's talk about x plus y equals to and less than 10. How did we get? That is through the each unit of product 2 has a profit of 70 and hours, 10 hours to assemble, 8 hours to finish. The firm wants to determine the quantity of each product to produce to maximize profit. So you see the constraint is already given that the maximum number of total unit can be in the warehouse is 10. So what does that mean? It means that the number of units of the product 1, number of units of product 2 must not be more than 10. Why? Because we do not have the space of more than 10. It was already given. So we have to manage it. So you see there are three constraints. Fourth one we have to make for the non-negativity constraints. A non-negativity constraint, so it is in every problem, but these three are the constraint of this problem, in which first is the product 1 and 2 assembling, product 1 and 2 finishing, and the product 1 and 2 warehousing. Third one is the product 1 and 2 warehousing. X plus y equals to and less than 10. So what you have to do, you have to solve these equations with the constraints, objective function with the constraint, and when you solve these constraints, you will get to know the x and y value. When you put the x and y value, you will have the maximum profit of function. You will have the maximum profit value. How you can find out the x and y value? Through the graphical method of the simplex, or you may use any software. Thank you very much.